Okay, good evening and welcome to 24 Hours of Pass Cross-Platform SQL Server Management. We're excited you could join us today for Guy Glanster's session, Monitoring Page Splits in SQL Server. This 24-hour Pass event consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when the recordings are available. My name is Jay O'Donnell and I will be the moderator for this session. I have a few introductory slides before I hand the reins over to Guy. If you require technical assistance, please type your question in the pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You are able to zoom in on the presentation content by using the zoom button located at the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. This will pop up at the end after the webinar ends in your web browser. I'd like to take a moment to thank our presenting sponsors, Microsoft, Quest, Idera, and SentryOne, supporting sponsor Redgate. The staging of 24 Hours of Pass would not be possible without their generous support, and they're the reason this event is available free of charge. If you would like to learn more about our sponsors and sign up for information on how they can help you, please visit sponsors page of the 24 Hours of Pass website. Pass Summit is Pass Community's flagship event, and it is happening November 6th to 9th in Seattle, Washington. Pass Summit is the largest conference for technical professionals who leverage the Microsoft data platform. Immerse yourself in deep dive technical sessions, learn best practices, and discover new tips and tricks. For more information and to register, visit passsummit.com. This 24-hour Pass session is presented by Guy Glanster. Guy is the leader of the Israeli Pass local group and also the CEO and founder of Madeira Data Solutions. His career has been focused on Microsoft data platform for the past 20 years, performing various database roles as either an on-site DBA, an external consultant, or a speaker. Guy is involved in many activities in the Microsoft data platform community. He occasionally speaks at community events such as Pass Summit, SQL Bits, SQL Saturdays, and user groups around the world. He also co-hosts the SQL Server radio podcast. So without further ado, here is Guy with monitoring page splits in SQL Server.
Thank you very much, Jay. Hi, this is Guy. Very happy to be here. I just have to say, let me go back. I usually don't look like this, but we had a costume party last month, so I thought it would be nice to put this one. So yeah, that's me. I'm based in Israel. It's 7 a.m. in the morning right now, when we actually have SQL Saturday in Israel today. So I'm doing this session, and then I'm right after the conference. Very busy day for me. But I'm happy to be here, and my session is monitoring page splits in SQL Server. And here's what we're gonna do. I'm gonna answer 3 simple questions. What is a page split? Why should we care about it? And how can we monitor page splits? And I think these are very important questions, and hopefully by the end of the session, you'll take some takeaways from this session, and you'll maybe rethink how you monitor and how you perform maintenance operations on your databases. So let's start. First of all, this photo is from maybe 8 years ago. I did this talk for the first time in the local Pass group in Israel, to the local community. And I put a clothesline, as you can see, on stage, and I put some pages. So this was to represent the lift level of an index, and those are the lift pages, of course. And then I started to tearing them up and moving them around. It was quite fun to demonstrate page splits. Obviously, I can't do that now. So I'm going to use this slide to demonstrate what a page split is. So here is a page, and that's a page split. Yeah, really. Actually, page splits in an index is when you build an index, you have a new index, the index has to be sorted. Let's say the index is by customer ID, that's the index key. It has to be sorted by the customer ID. And then someone inserts a new row into the table with a customer ID, and the customer ID doesn't have to be necessarily the last one. It's some value of customer ID, and it has to be inserted in the right order in the index to maintain the sort order of the index. Now, there is no room in the leaf level of the index in the relevant page to put the new row. So what happens is SQL Server has to perform a page split. It allocates a new page somewhere on this. It's probably not in the same location because it's full. Okay, so it allocates a new page. It moves 50% of the page of the original page to the new allocated page, and then there is room for the new row to put in the original page. It also has to maintain the pointers between the pages in the leaf level of the index. So that's quite a lot of operation to perform. And why should we care about page splits? They happen all the time. It's part of how SQL Server works. It's part of how indexes are maintained. We should care about them because first, it affects performance of insert and update operations. Whenever we need to insert or update something in an index and it causes a page split, then this specific statement, insert or update, will suffer from this extra allocations and moving rows around and so on. There is some memory and I/O and CPU resources involved here. So it's going to affect our DML operations. It also creates fragmentation. Okay, so if we have a lot of page splits in an index, we're going to move a lot of pages and data around. We're going to have fragmentation. This means that the logical order of the rows or the pages in the index is not as the physical order of the pages on disk. This means if we perform a scan operations, we need to scan the entire leaf level, all the pages in the index, then we have to jump from one page to another in different locations on disk, and this becomes not a sequential I/O operation. It becomes a random, more like a random I/O operation. We have to move the disk around, and this really affects performance. Okay, so the scan operations will suffer from that. But you should realize that it's only for scan operations. If we have a very optimized workload, and for all the queries that we run, we get seek operations on the index, then fragmentation and page split might not be such a big deal in this case, because if we have very optimized seek operation and we are just searching for a single row, for example, then it's going to be very fast to just locate. We start from the root page of the index and we go to the intermediate level and then to the leaf level page. We locate a specific page we need and that's it. So we don't really care about fragmentation in the leaf level. Having said that, you should also remember that sometimes we see an index seek operation, but this index seek operation actually is more like a scan because it looks for many, many rows. Let's say I have a select from transactions table where date, time between 10 years ago and now. Okay, so I'm gonna bring a lot of data in and I have an index on date time and I get an index seek, but this index seek will actually scan a lot of pages in the leaf level, so it's more like a scan, so we'll still suffer from the fragmentation effect. The next thing is this takes us more to the monitoring part of this session. If we monitor the system and we see a lot of page splits, we see that the number of page splits increase over time, then this might indicate a performance issue and something that we need to do something about it. So it's good, the good thing to monitor page splits. And if we monitor page splits at the index level, so if we know how many page splits we have over time on every individual index, this can help us determine what should be the best fill factor for that index. Now, the fill factor is determining how much space you leave empty on each one of the leaf level pages when you build the index or rebuild the index. So it's just only when you create an index or rebuild the index, you can say fill factor 80%, for example. This means you're going to fill up only 80% of the leaf level pages and you're going to leave 20% empty. And this is exactly meant to avoid the page splits. Okay, so the next time an insert comes, there is room for that new row and you don't need to do the insert. And there is some calculations and monitoring and planning that you need to do in order to determine what would be the best fill factor value. Most people, most systems, most organizations either don't do it at all. They just don't maybe even know about the existence of the fill factor property. In many cases, I see DBAs just use a magic number like 80% for all indexes. But actually, the best way would be to determine the best value for each index because different indexes require different fill factor values. So this is why we should care about them. And now, if we want to monitor page splits in the system, how can we do that? So I have here several options. Usually when I do it live, I do it like a survey, but I'll just tell you, okay? So one option is to use performance monitor, and I will, of course, demonstrate that in a minute. Another one is to use profiler. We can use dynamic management objects or views or just DMVs. And of course, extend events, okay? So those are the 4 options we can use to monitor page splits. And I can already tell you that profiler is not an option, okay? In profiler, you can start a trace and you can choose which events you want to monitor, and there is no such event as page splits or anything similar in profiler, okay? You just can't use this tool. It doesn't exist in there, so that's not an option. But we still have performance monitor, dynamic views, and extend events, and this is time for the demo. Okay, so I have here a database. Currently it's empty. I just created it. It's called page splits demo, and I want to start with the perfmon. So let me go to performance monitor. In performance monitor, when you install SQL Server, you have a set of objects and counters related to your SQL Server instance. One of them is called access methods, and inside access methods we have 2 interesting counters. One of them is page splits per second. The other one is called pages allocated per second. And I want to look at both of them. Okay, so let's do this. All right, so sitting here, currently there is nothing, it's 0, nothing is happening on my system. And let's do some things. Okay, so I will create a table with random values. It has a GUID column, unique identifier, which is random by nature. Okay, I'm using fill factor 100 on purpose. I don't want to leave any space. I want to have page splits. And then I have an endless loop to just insert rows. I use the new ID function to generate new unique identifier values, random values, as far as I care. And we can see now that we have some, let me do this, okay? So we have page splits, and we have page allocations, and it's hard to see, but I can tell you that they are just one on top of the other, okay? So the graphs are identical right now. We have the same value, or you can see some differences here, but they are practically the same. The number of page splits per second, the number of page allocations per second is more or less the same. And this indicates the workload that I'm doing now, because I insert random values. We have to move things around all the time. We have lots of page splits. Okay, so it's around, no, sorry, something like 10 on average per second, something like that. Okay, but there is no difference. So we have page splits. They're also counted, of course, as page allocations, because each time we have a page split, we need to allocate the page. This makes sense. Okay, so we have one option to monitor page splits, but this will only give us the total page splits on the instance. I want to see the difference. Okay, so now let's create a table with an identity column. So this means every insert will insert a new row, a new value, which is the last value in the index, because it's ever increasing. Okay, so in this case, I don't expect any page splits because we only put rows at the end. We do the same thing. Okay, so now if you can see, it's actually the same. Okay, we have page allocations, of course, because we insert more and more rows to the index, but we also have page splits, and they're the same still. Now this is weird, because I expect in this case to see only page allocations but not page splits. We shouldn't have page splits because we never insert rows in the middle of the index. It's always at the last page of the index. Okay, so this is weird, and let me stop that. Okay, so we can't use perfmon. The problem is that when Microsoft says page splits, they actually mean page allocations. So any type of page allocations is considered, this is not exactly a bug, it's a matter of terminology. Okay, when DBAs say page splits, we actually mean the page splits that are rows that are inserted in the middle of the index, and then we need to allocate new pages and move the 50% of the page, move that around. These are page splits as far as I'm concerned. As far as Microsoft is concerned, a page split is any type of page allocation in an index, even if it's the end of the index, like in the identity case. So it doesn't really help us. It doesn't really help us to distinguish that there is no distinction between those two counters in this case. So we can't use that. Let's close it. So let's move on. Let's try to use dynamic management objects. Okay, I love dynamic management views and functions. They are really handy. You can do a lot of things with them very easily. They are available to you. Just write your select statements and get the information you need. You don't need to set up any trace and export data or anything like that. Let's drop the two tables. And then create a new table with random values. This time I'm using an integer here, and I'm using on purpose another car column, which is got 2000. Every data page in SQL Server is 8 kilobytes, right? So this means we're gonna be able to put 4 rows in each page, not more than 4, because we get to the 8K limit. Okay, so this is the table. I want to show you through this DMV, sysdm-db index operational stats, some information about the index. Okay, so I have the clustered index on the primary key on the int column. And as you can see right now, we have nothing. Okay, we just created a table. We still don't have any rows. We still haven't allocated any pages. So the leaf insert count is 0, the leaf allocation count is 0, and so on. Now, leaf allocation count, if we look at MSDN, then the description of this column says this is the number of allocations, page allocations in the leaf level of the index. And it says for an index, this corresponds to page splits. Okay, so I said, great, I can use this one to monitor page splits in each and every index, which is a great thing. So now what I'm going to do, I'm going to put 20 consecutive rows in the table. I'm using row number to sort them, and I multiply by 2 to leave some room for new rows that I will insert later on. So currently I'm inserting rows 2, 4, 6, 8, and so on until 40. Okay, 20 rows. Since we say we're going to have 4 rows per page, we're going to have 5 page allocations in this case, 5 pages in the leaf level at least. Okay, so now I'm going to use another DMV to show you that we have 2 levels in the index. So this is the root level. We have 1 page in the root level, and this is the leaf level with 5 pages as we expected. Okay, so far so good. And I'm going to use another one, database page allocations, to see all the locations in this index. So we can see here that we have the index allocation map page, we have the root page of the index, and we have all the data pages. Okay, so this is the first page, the previous is null. Okay, and the next page, this is the page ID, the next page is this one, here is the next page, this is the previous one, the next one, and so on. So it's a linked list in both directions in the leaf level index, and this is the last page of the index. And operational stats, that's the last one. Okay, so we have leaf insert count. We inserted 20 rows into the leaf level of the index. We allocated 5 pages in the index. Now that's a problem already, because I told you that this, according to MSDN, corresponds to page split. We didn't have any page splits yet. Okay, we just allocated new pages at the end of the index, and still it counts all those allocations. Okay, so you see where I'm going. I'm going to put a new one, a new row in the middle of the first page, actually, because currently the first page includes 2, 4, 6, 8, and I want to put 5. So now there would be a page split. We can see now that we have 6 pages in the leaf level of the index. And we can see that things move around. Well, it's hard to follow right now, but there is a new page. Okay, it's 998. So now the first page points to 998, which is elsewhere on disk. And this page now points to 994, which is this one, which was the second page before. Now it's become the third page, and so on and so on. Okay, so this is what page split does. And if we look here, okay, so now we have 6 page allocations. So again, there is no difference between, I call them real page splits and fake page splits. Okay, so there's no difference between the fake page splits that are actually page allocations at the end of the index and the real page splits in the middle. We can't distinguish between them. Okay, so it also doesn't help. So we move to extend events. Extend events is a great monitoring platform. I'm gonna do it again, the same table. And I'm gonna start an event session. Of course, all those scripts are gonna be available to you after the session. I'm gonna talk about it in the end. So yeah, let me delete them. Page splits demo, okay, this is fine. So I'm creating an event session, and we have a page split event. How about that? Okay, so that sounds great. This is exactly what we need. Each time we're gonna have a page split anywhere in the database, I'm gonna have a page split event, and I wanna get the SQL text for that, that corresponds to that page split. I'm gonna put it in the file here, and that's it. Let's start the event session, create, start. All right, so it's up and running. We go back to our database, and I'm doing just like before, but now let's do it one by one. Okay, so first I insert the first row with int column 2, and I have here, I won't go into details about this, I'm using xquery to query the event data. So what we have here, this is the partition ID, and we have an operation. This was a page split operation. The split operation is split empty B-tree. So for the page split event in extend events, we have different sub events, or it's called split operation. There are different types. In this case, it's split empty B-tree. Okay, and we see the insert statement here. So this is what happens when we insert the first row. Okay, we need to start creating the B-tree. It was empty. So this is the first one. I'm going to have a more complicated select because I'm joining to some other tables to get more information. Okay, so I know that this one is on the random values table, the clustered index, and I have all the information as I had before. I'm going to insert the next row now, the second one, and another one, 6, and then 8. Okay, so I have 4 rows. I filled up the first page, and now I'm going to put the next one, the 5th row, and the second page. So actually, so far we had a single page in the index, and now we have to split. We have to have a root page and 2 leaf level pages. Okay, so this was the first one. Now we have split for insert. This is for the allocation of the new page in the leaf level, and we have split for root node. Okay, in order to allocate the root node of the index. Okay, so we have quite a lot of information here about what's going on through extend events. This is great. Now we're going to create a page split, a real page split. I'm going to put the value 5, and there's no room in the first page. We have to allocate another one and do a page split. Sorry. And let's see what's going on. So now I expect to see a split operation of something that represents a real page split, but I see a split for insert. So as far as you can see, there is no difference, as far as I can tell, between those two events. This was a regular allocation of a new page in the index, and this is a real page split. I cannot distinguish between them also in here, unfortunately. Okay, we have the split operation values, so they are pretty it's pretty detailed. We have 7 different values for the split operation, so I would say surely one of them would be a real page split. Unfortunately, no. We have all kinds of different so-called page splits in the system. None of them is the page splits that we DBAs talk about, the real page splits, unfortunately. I don't know why. I would really expect it to be here somewhere, but it's not here. So let's just stop and drop the event session. All right, back to the presentation. So unfortunately, we can't use this, we can't use this, we can't use this, okay? And for the same reason, because Microsoft does not monitor, or it does not represent real page splits in any way. Page splits are page allocations in indexes, all types of page allocations, and there is no way to distinguish between them. Okay, so that's how it is. You just can't monitor the real page splits in SQL Server. I'm sorry. I'm just kidding, of course. Okay. Before I move on to show you how you can really do it, Jay, do we have any questions?
No, I don't see any questions right now, Guy.
All right, so let's move on. Great. So there's actually a 5th way, okay? And the 5th way is the transaction log. So each database, of course, has the transaction log, and everything is written in the transaction log. When I say everything, it's really everything. You have lots of information in the transaction log, but the content of the transaction log is undocumented, it's unsupported, it's not something you should use. Well, you might be able to use it, but it's not supported. You should be careful when you're using it, and it's not documented. It's not very easy to find your way around inside the transaction log, but there are ways, and I want to show you what you can do with it. Okay, so let's do the demo about that. Let's drop the table again, create the table again. Okay, so there is a function called sysfndb log, and this function will give me the content of the transaction log between two LSNs. Okay, log sequence number between this one and this one. In this case, I put null and null, so give me everything. Now, this is something you want. Again, first, sysfndb log is not a documented or supported function, as far as I know. And regardless of that, you should be careful using it, because in a production system, a busy production system, you're going to read from the transaction log, from the log file. It's going to put some stress on the log file, which is probably busy already. So you should be careful using it. And I'll show you how to use it and in which way. So here is the transaction log of my database. Of course, this is not a busy production system, but you can see that already there are lots of stuff in here. I'm not going to get into too much details, but we see the LSN, the log sequence number of each entry in the log. We see the operation. So this is, for example, everything starts with LOP, log operation. And we have a begin checkpoint, for example, modify row, insert rows, commit transaction, okay, and so on and so on. And for each operation, we also have a context. Okay, so sometimes we don't have a context. Sometimes it's the clustered or the schema version or a boot page checkpoint, and so on and so on. So there are all kinds of different contexts. And then we have more information, the log record length, for example. There is the allocation unit. Okay, we have the allocation unit name, which is something I'm not going to use, because for specific log operations, this will give us the index name. Okay, so I know which index it corresponds to. And there is a lot more information later on we're not going to use. Okay, so first of all, my database currently is in the simple recovery model, so we don't need to back up the log. For the sake of this demo, I'm just going to do a checkpoint. When I do a checkpoint, the log is truncated, of course. So now if I look again using fndb log, this is the content of my transaction log right now. Okay, so we just have the checkpoint itself. Everything before the checkpoint was truncated. We have the begin checkpoint operation. We have the checkpoint itself. Okay, and we have the end checkpoint operation. Okay, so this is how it looks like in the transaction log. Now I'm going to insert the first row. Remember, currently there are no pages allocated to the table. It's empty. I'm going to insert the first row, and I'm going to look in the transaction log. Look at this. Look at how much stuff, how much information is written to the transaction log when you just insert a single row. Well, in this case, it's not just a single row, it's the first row, so it has a meaning. But a lot of things have to do behind the scenes when you insert the first row in a table. You need to do a lot of allocations. You need to change a lot of metadata pages, like the GAM page, for example. You need to set some bits in there, and also the PFS, the page free space page. You need to modify a row in there, and lots of stuff, format page and set bits and create allocation and more and more. Let me see where it is. Somewhere in here we also have, oh yeah, at the end, insert rows. Okay, so this is actually the entry that insert the row itself into the index, and we can see according to the log record full length. Okay, so we have here 2000 bytes, because this is the length of the row itself. We have the, remember, the car column with 2000 bytes, and we can see here the name of the table and the name of the index, the clustered index. So I know exactly where it goes to. Okay, and of course there's a transaction. Even though I didn't specify explicitly begin transaction and commit transaction, I'm using the auto commit by default, which means every single DML statement is inside a transaction. So we can actually see the begin transaction and the commit transaction. So this is the commit transaction, and the begin somewhere here. There's one here and one here, because SQL Server does other things behind the scenes. They are also inside transactions. So we have lots of begin transactions and commit transactions events as well. So let's do the checkpoint again, because it's too much mess. And let's insert the second row. So now we've already allocated all the pages and done all the things we need to do. So now it should be much more simple. Okay, so we have those 3 rows are for the checkpoint, and those are for the row. Okay, begin transaction, insert the row with the same size as before, commit transaction. Okay, now it's quite simple. Let's insert the 3rd row. Look again. Okay, so it's the same thing, another 3 entries, and the 4th row. You get the idea. Let's do a checkpoint. So now we have a full page, the first full page. And now I'm gonna insert the 5th row. Now we need to allocate a new page. It's not a real page split, okay? It's a fake page split, as we called it. So we allocate a new page at the end of the index for the next row. So we expect a lot of stuff in the transactional peak because we have a new page allocations. Okay, so right. So as you can see again, we have the all the transactions and the format page and where is it? The PFS, and so on and so on. Okay, so we do a lot of stuff and then we insert the new row, but this is not a real page split yet. Okay, look here, we have a begin transaction of a split page. Okay, so it's still called a split page, but it's not exactly the page, the split page we are talking about. It's not a real page split. Let's do a checkpoint. And now let's insert the value 5, which will cause a real page split, just like before, because it has to go into the first page in the index. And let's look at the transaction log. Okay, so again, we have lots of stuff because we did page allocations, and we have to change stuff. We still see the split page here, but I can tell you that, where are you? There you are. Okay, this operation, LOP delete split, okay, and it has, sorry, the delete split, this one is the first time that we see it. When we have fake page splits or any type of page allocations in an index, which is not the real page splits we are looking for, we will not have this operation. Only with the real page split, we will have this operation. What this operation means, when we have a real page split, we need to allocate a new page. Okay, this happened somewhere before, and then we need to move 50% of the data from the original page. It's this one. Okay, we do insert rows, and look at the size. This is half the size of a page. Okay, it's half of 8K, and this is because we move half of the contents of the original page to the new page. Okay, so this is the first part we do in the page split, the real page split, and then we need to delete that half that we just moved from the original page. We need to free space in the original page. So we have the delete split, and this is the only place that we do this operation of LOP delete split. Okay, so if we can monitor this log operation, we can actually monitor the real page splits. And it's the first time that I show you something that can distinguish between real page splits and fake page splits. Eventually, of course, we do the regular insert row. Okay, so this is the actually row with the value 5 going into the original page now. So now that we have this, let's experiment. Just like in the beginning, I have the table with the GUID column with the unique identifier, which should have lots of real page splits. And I also have the identity table, which shouldn't have real page splits, only fake page splits. Let's do a checkpoint. And now, because I don't want to, during my experiment, I'm going to insert lots of rows into the 2 tables. I don't want checkpoints to come in the middle and delete the contents of transaction log. Then I'm going to change the database to recovery full. And I also have to take the first full backup. Okay, so from now on, until I back up the log, the transaction log will not be truncated. Okay, so I can count on it to have all the information I need. And now I have one loop inserting 10,000 rows into the random values table. Let's wait for a second. Got it. And another loop, inserting 10,000 rows into the identity table, which should have only fake page splits. And now what I'm going to do very easily, I'm going to use the same SDB log, group by allocation unit name, which will give me the index name, and of course, give me only the LOP delete split operations. Okay, so I'm going to count how many such events, such operations we have for every index in my database. And look at this. We only see the table with random values. Okay, we don't see at all the table with identity because there are no real page splits at all in that table. But we have 228 page splits out of 10,000 rows we inserted in the random values table. Those are the real page splits. So for the first time, we can now monitor the real page splits by using the transaction log. Okay, so this is a great thing, but it's not the best thing. Let's go back here. It's not the best thing because you need to monitor the transaction log itself. And like I said, in a production environment, that might be a problem. That might incur some overhead. And also, you need to use SDB Log, which is not a supported function. And also, you need to rely on the contents of the transaction log, which is also something that is not documented. So it's not a very good solution. It's the only solution that existed before SQL Server 2012. Okay, and the first time, I did this presentation 8 years ago. It was before 2012 was released. That was the best option I could give the audience. But fortunately, since 2012, we have even a better way. Okay, and a better way is going back to extend events again, but in a different way. Okay, so now what we can do, let's change back to simple. Let's drop the two tables, create them again. Same two tables with a unique identifier and identity. And let's see, the DB ID is 13. Okay, it's at 13 already. So now I'm going to create a different event session. And this time, I'm not using the page split event, I'm using the transaction log event. Okay, so this is something that was new since 2012. We have the transaction log event in extended events. This means that whenever a transaction log operation, an LOP, is written to the transaction log, we're going to get an event through this event session. And I'm going to add a filter, give me only the LOP delete split events, which is operation 11, and only for my database, because it's a server-wide event session. And one of the nice things about extended events, we can use different types of targets, not just write everything to a file. We can use the histogram target, which means we're going to group by the allocation unit ID, and we're going to have the count, the number of events per allocation unit ID, which corresponds to an index. Okay, so we don't have this. This incurs much less overhead because we don't put everything that we monitor in a file or something like that. We just maintain a very small histogram in memory, just one value per index in the database. So let me create this event session. Let's start it. And the same thing. Okay, so the first loop, 10,000 rows into the random values table. This will create many real page splits. And then another loop to insert 10,000 rows into the increasing values. This will create a lot of fake page splits. And now, by using this very long query, okay, this will create the histogram and join to some tables, some catalog views. This will give me, again, as you can see, only the random values appear because there are no page splits at all, no LOP delete split events for the increasing values table. And for this specific index, I have all the information, the table name, the clustered index, the name of the index. We had, in this case, 223 page splits, real page splits, okay? And I also added the fill factor because it's very relevant, okay? So I can look now, imagine you have a production system with many, many indexes in your database, of course, and you have here a very clear view for each and every index in your database, what is the fill factor you used and how many page splits you had since the last rebuild or since the time you started the session or whatever. Okay, so it's a very good monitoring tool for monitoring the real page splits per index in your database. Let me stop and delete the event session, and we go back to the presentation. So we have a winner. According to as of today, this is the best solution to monitor real page splits in SQL Server. It's still not ideal as far as I'm concerned, because we still rely on the contents of the transaction log. As I said, it's undocumented, but it works. This content, we rely on the LOP delete splits operation. It hasn't changed since ever, as far as I know. So hopefully it won't change in the future. But yes, it's not supported, not documented at least. So it's a bit of a problem, but still, this is the best way. It's much better than relying on the SDB Log function. Another reason why it's better is because we have an event session. So whenever we have this event, it's going to count the event in our histogram, and we don't have to make sure that we pull the information from SDB Log frequently enough. We don't lose any data and stuff like that. So it's much easier to use this method to maintain. It doesn't have much overhead on the database. So yeah, I think it's a great solution. Not the best, but the best one we have. So let's summarize. Again, when Microsoft says page splits, they actually mean page allocations. It's very confusing. It's misleading, I think, because actually not most, all people that I know, all DBAs that I talk to, when we say page splits, we mean the real page splits in the middle of the index. But unfortunately, for some reason, Microsoft uses a different terminology. When Microsoft says page splits, it actually means all types of page allocations in an index. Okay, and again, for some reason, Microsoft doesn't represent the difference, the real page splits anywhere, not in Perfmon, not in the DMVs, not through extend events. As I showed you, we have a specific split type operation in the page split extend event, and there is no such thing as the real page split. We cannot use it. So prior to SQL Server 2012, the only way to monitor real page split is to use the undocumented function SDB Log. Starting with 2012, you can use the extend events with the transaction log event, and then we can filter only the LOP delete split log operations. And what I wanted you to take from this session is that if you have a good monitoring solution like I showed you, and you monitor the page splits over time, then you can actually optimize each index individually. And think about it, there are indexes, there are tables where you have an identity, for example, and you only insert rows in the end of the index, so there will never be page splits. And for such an index, you actually want to use a fill factor 100. There's no reason to leave empty space and to waste that space, because you're never going to use it, right? On the other hand, for some indexes, you might have lots of different values coming all the time, and they're random values. You will have lots of page split, and then you want to have maybe even 70% fill factor. You want to have enough space for new inserts, while for other index you might want to use 80%, 90%. If you just use rule of thumb and just use let's say 80% for everything, it might be good enough, it might not be good enough. It's not the best solution. Okay, and for some workloads, for some environments, it might make a real impact if you optimize and use the best values. And the best thing to do is to come up with the best fill factor value for each and every index. For that, you need to be able to monitor page splits for that index. So some best practices to take away before we summarize the session and leave time for questions. So first thing, of course, you need to rebuild your indexes on a regular basis during a maintenance window. Okay, some systems have a maintenance window every night. Some systems can do it only in weekends. Some systems are true 24/7. You never have a maintenance window. You need to come up with some kind of a maintenance window. You need to find the time of the week where you have the least traffic, and do something, not everything at once, or maybe build index once in a while, spread it over the week. You should use rebuild online to not block your operations, and so on and so on. So there are all kinds of best practices, but you should rebuild your indexes. You should have a good maintenance plan in place, taking into account your specific environment to make sure that you rebuild your indexes on a regular basis. That's the first thing. Second thing, monitor page splits. Okay, the way I showed you, you'll have the scripts, you can use them in your environment, test them, play with them, that you feel confident with them, and then deploy them to your production system to monitor your page splits on all of your index on a regular basis. And then adjust the fill factor. Okay, so now let's say you have a weekly maintenance window and you rebuild your indexes every week and you monitor page splits over time. So for one index, for example, you can see that you have a very little number of page splits after a week, and the fragmentation is quite low. Then maybe you can increase the fill factor, because you don't need, let's say it was 80%, you can try and increase it to 85% or maybe 90%, because you don't need all that space empty, because you don't have so much page splits. But for another index, you started with 80%, you have lots of page splits, you might want to consider to lower it, the fill factor to 75%, maybe 70%. So it's a trial and error. Okay, you can fine tune your page split, your fill factor, sorry, for each index based on your monitoring, and it also, of course, depends on the time between rebuild, between maintenance windows. Okay, so if you take all of that into account, you can actually optimize your fill factor for each and every index. I should say that it's also very important to monitor recompilations. One of the things that happen kind of as side effects when you rebuild your indexes is actually, when you rebuild an index, you also update statistics for that index. And when you update statistics, the next time someone is going to use a query or a store procedure that relied on the previous version of the statistics, it's now out of date. SQL Server will recompile that query or store procedure, and when it recompiles, it will generate a new plan. Sometimes, for all kinds of reasons, the new plan might become worse, might be a poor plan compared to the previous one, and you won't even know about it, and you won't even know why suddenly performance is poor in your system, because there was an index rebuild, update statistics, and the recompile, and now you have a poor plan. So it's important to monitor recompilations as well. You need to know when recompilations happen, for what reasons they happen. You can use extend events for that, or Profiler. There are events for recompilations, and you can monitor, you can track the reason. There is a field for that, the recompilation reason. There are all kinds of reasons. So it's important to do that as well. It's out of scope for this session. I cannot show you this right now, but you should do it as well. And when it happens, when you have a recompilation and you have a new plan that is now poor, it's different from the original plan, then if you are on 2016 or 2017, you can and should use the query store. The query store, when you enable it, it will start accumulating statistics about executions of queries, and also it will store all the historical plans. So you have the current plan for each query, and if there was a previous plan and it was replaced by a new one, you'll have the previous plan as well. So you can get all that information from the query store, and you can use that when you have a poor plan, either to force the original plan. Very easily you can say, okay, I see that now there is a new plan and it's not good at all, but there used to be a plan that was very good before. Here is the previous plan, the good plan. You can now force the good plan and say, okay, go back, revert to the previous plan and use that. Okay, that's one option. Another option, if you don't want to force it, you can at least see the two plans very easily in the query store. You can compare between the plans, you can see what changed, what happened, you can investigate, and then you can try and optimize the query to make sure that it always uses a good plan. Okay, so those are the best practices I can recommend related to this topic, and that's it. Time for questions.
Okay, I've got a couple of questions here. SDB Log can impact the T log, but what's the impact on the transaction log using the transaction log extended event?
Okay, so there is a difference. If you use SDB Log, you actually scan the transaction log file. You go to the file, you read the file from LSN to LSN. You have I/O, you have lots of operation. When you use the extend events, then whenever a transaction happens, you have a new transaction. The transaction is first written to the transaction log buffer in memory, and then when there is a commit transaction or the buffer is filled, it flashes the content of the transaction log buffer from memory to the transaction log file. With extend events, when it's on, whenever you have a new entry in the transaction log buffer in memory, you already get an event about it in your event session, even before it goes to the file. Okay, so everything happens in memory. It's much faster. And also, if you use the histogram target, then the override is really, really small, because you just update the counter in the histogram for that event, and that's it. You don't need to scan the entire transaction log file each time, look for the relevant operations. That's a big difference.
Okay, next question. How about page splits for non-leaf levels? How do you differentiate splits for those from leaf level splits?
Okay, so that's a good question. I didn't talk about it at all. Not only in the leaf level, but also in the non-leaf level, in the intermediate level, we might have page splits. If we insert rows in the middle at some point, we also need to allocate a new page in the intermediate level of the index. So we need a way to monitor. We can monitor those page splits as well. I didn't do it because I think it's not very important. The amount of page splits that you will have in the non-leaf levels is very, very, very small compared to the page splits in the leaf level. So we really care about the page splits in the leaf level. It's like compared to zero if we want to compare between them. So I don't think it's worth the effort to distinguish between them or to monitor it all, the page splits in the non-leaf level of the index. But you can do that using the same technique.
Okay, the next is more of a comment. It's, I can't believe I've been so wrong for so long about page splits. Seriously, Guy, we'll definitely be using this, and it will be going into our DBA training plan.
Great. Yeah, I know. I was also surprised when the first time I realized that the page splits that I was always looking at, whether it's Perfmon or the DMVs, are not really page splits. I know.
All right, the next one. Page split happens for non-clustered indexes also, as a question. Yeah,
sure. It's the same thing. In non-clustered indexes, you have the leaf level. The leaf level pages are full. You need to insert a row into an entry into the index pages in the leaf level. You have the same problem. There's no room. You need to allocate page, move 50%. It's just the same. It's more of a pain in the clustered index, okay? Because that's the table itself. You move things around. It affects performance harder than with non-clustered indexes, but it's the same thing. Okay, it's a big deal for non-clustered indexes as well.
Similar question regarding column store indexes.
With column store index, no, this is a different thing. Column store indexes are built in a completely different way. They are not B trees. So the internal structure, how they are built, how rows are inserted, there's something called the delta. I forgot the name of it. You put new rows in a separate location. Okay, you don't put them in the middle of the index like you do with B trees. So it's a completely different structure and mechanism to maintain them. So there is no thing like a page splits in column store indexes.
Okay, the next question. What about monitoring the splits of pages that hold secondary indexes?
Splits of pages that hold secondary. I'm not sure I understand the question.
Yeah, I'm just reading it as it came. What about monitoring? Yeah, I'm sorry, I don't have any more than that. Should I move on to the next?
Yeah, sorry. If you can repeat the question again, maybe.
Okay. What about monitoring the splits of pages that hold secondary indexes?
Secondary indexes. Sorry. No, if the person who asked the question maybe can ask the question again, because I don't understand the meaning of secondary indexes in this context. Sorry.
I'll move on to the next then.
Okay.
Why haven't Microsoft provided a much more obvious way of seeing these page splits? It's been a performance issue since the very first version of SQL, and still no better tool.
Yeah, sorry about that.
And yeah, that was, let's see. That's the last question so far. I don't see anything else coming in yet, Guy.
Okay, great. So I just want to say that the presentation itself is already on the PASS website, and I will make sure that the demo script that I just showed you will be there as well, I guess in a couple of days. I will also publish the content on my blog, so you can find it there. And if you have any more questions or you want to talk to me about this stuff or anything else, actually, then you can find me either on Twitter or LinkedIn or on my blog. Just search for my name and you'll find me somewhere. So I'll be happy to help if I can.
Okay, thanks very much, Guy. Make sure to stay tuned for our next session, modernizing mission critical apps with SQL Server 2.17 on Windows, Linux, and Docker containers with Mark Hatai. Thank you all for attending.
Thank you. Bye-bye.
Goodbye.